Hey everyone, this video is about dividing polynomials, and I just want to spend some time reviewing two forms of dividing polynomials. So one way is to use long division. All right, so if we had this trinomial here and we wanted to divide by x plus 3, we could use that form of long division where we would put, the trinomial here as x squared plus 10x plus 21, and we're just dividing that by that x plus 3. So this process is very similar as if we were to divide 672 into 21. Okay, we would look at this and say, hey, how many times does 21 go into 6? Nope, does not happen, right? So then 21, does it go into 67? Yeah, right, it goes into it 3 times, right? So 3, then we multiply with the 21, and we end up getting 63 here, right? Okay, and then from there, we subtract this number, so we end up getting a 4, right? 67 minus 63 is 4. Bring down this next term, next digit, if you will, which is a 2, and then you look to see, hey, does 21 go into 42? And it does, twice. So then you go 2 times 21 again, which is 42, and we subtract that 42, and that gives us a remainder of 0, right? So this remaining value here is typically what we call the remainder, and up here is what we call that quotient, okay? So we're going to use a similar process, of course, with polynomials, a little bit trickier, but let's try to use the same idea, okay? What can we do to x so that it goes into x squared? Well, we'd have to multiply this x perhaps by another x, right? So x times x would give us that x squared. So I'm going to go ahead and just align it up here. And so multiplying it by an x. So now x times this x right here, we're basically going to multiply everything by this binomial that we end up getting up here. Okay, so x times x is x squared, and then x times 3 is 3x, right? Now what do we do with this stuff? Remember, we subtract. So put a minus and a minus, and this should cancel out your x squared. So then 10x minus 3x turns out to be 7x. And then bring down your next term, right? That's plus 21. So now same thing. What can we do to this x so that it goes into 7x? And that's multiplied by 7. So I'm going to put here plus 7, and then just start multiplying that 7 times the x again, which will give us 7x, and then 7 times the 3, which of course gives us 21. And then remember, always subtract this stuff down here, so minus minus, and this will cancel, we end up with a remainder of 0. So that means that our quotient here would be x plus 7. Okay, so that's the long division process. And now I just want to take some time and go through maybe another question, and then we can jump into like synthetic division. Okay, so here we have long division again, and you can see that the polynomial is a little all out of whack, right? So I like to always set it up into my long division, and when I redo that, or when I set up my question here, I want to put it into standard form. So that means 6x cubed should go to the front, followed by minus x squared, followed by minus 5x, and then plus 4. Okay, now what can I do to 3x? So that it goes into 6x cubed, and that means I need to multiply by a 2, but also by x squared. So I'm just going to align that up here with the x squared, multiplying it by 2x squared. And now remember, we just want to multiply everything up here into this binomial, okay? So 2x squared times 3x gives us 6x cubed. And then 2x squared times negative 2, well, that gives us negative 4x squared, right? Now remember, what do you do with this stuff? Oh, we always subtract, right? So put a minus here, put another minus here, and you'll notice, oh boy, that changes to addition, right? So be careful with the minus minus. All right, this is going to cancel. Negative x squared plus 4x squared should be 3x squared. And then bring down your next term, please. Okay, now from here, 3x. How do we get it to go into 3x squared? We multiply it by another x. So I'm going to put here plus x, and then get that x to multiply into everything. So x times 3x, 3x squared. X times negative 2 becomes minus 2x. All right, what do we do with this stuff? Well, we always subtract, right? So let's put a minus here, and you'll notice it happens again. Let's change that to addition. All right, okay, so what could we do? We get rid of this first term, but we get negative 5x plus 2x, which becomes negative 3x, and bring down this plus 4, okay? All right, one more time, right? 3x, can it go into negative 3x? If we multiply it by a negative 1, so let's put here negative 1 and get that multiplication going. Negative 1 and 3x becomes negative 3x. Negative 1 and negative 2 becomes positive 2. But what do we do with this? You got it. We subtract. We subtract. Right here again, negative, negative. Make that into a positive, right? And we are ready to go. Let's see what we end up getting here. This cancels. Okay, and we get 4 minus 2, which turns out to be 2. Now that tells me that this is my remainder, and that tells me that this right here is my quotient, okay? All right, so good question here. You can see we did get a remainder, and a good way to write our final answer, by the way, could be 2x squared plus x minus 1, and then we would add our remainder over that divisor, 3x minus 2. Okay, so this is how I could write out my final answer there if I wanted to include that remainder. Okay, let's talk about synthetic division. Synthetic division is a nice shortcut, right, to using long division, but we usually use it when we have a more basic divisor, okay? Something like x plus some value, let's say x plus c or x minus c. And the way this works is, okay, if I were to take this and make it equal to 0, I could add that c to both sides, and then I just get c, right? So it's almost like testing out your 0 or your solution, right? So, if my factor is x minus c, I'm going to be testing out positive c in synthetic division. Whereas if my factor is x plus c, I'm testing out minus c into synthetic division. Okay, now let's swap out the c's for some numbers here, and let's take a look. Here we're dividing by x minus 3, right? Okay, so the way synthetic division works is, some people prefer it because we really don't need to use the variables until the very end. Okay, so x minus 3, well, we're going to use positive 3. And now I'm just going to take the coefficients from this entire polynomial, which would be 1. I'm just going to throw them up here. Leave a line in between, please. Let's put 4 for the x squared now. Okay, then we go to x, right? That's negative 5 as the coefficient. And then we go to the constant, which is 5. Now, if you're ever missing a term in between, like if you jump from x cubed to x, you would be missing that x squared. You want to put a 0 almost as a placeholder there, okay? All right, the way we start synthetic division, we bring down that first term, and we do the multiplication always with the stuff on the outside. So 3 times 1 gives us 3. That's just going to get put right here in the next column. Now this is positive, right? So we get to add. 4 plus 3 is 7. Multiply 3 times 7, which is 21. And then negative 5 plus 21 should be 16. And then 3 times 16 should be 48. So 5 plus 48 should give us the 53, and 53 is actually going to be our remainder. All right, so now what we're going to do is write out our final answer, and we're just going to work backwards. Remember, this is the remainder, so this is going to be the constant, this is going to be the x, this is going to be the x squared. And if you notice, what happens here when I write this out is I drop a degree. I go from x cubed to x squared. All right, let me just write out my remainder over my divisor there. Oops, that's x minus 3. Here we go. Okay, so that's going to be that final answer. And again, we went from x cubed to x squared. All right. Okay, let's take a look at another example. And what that's going to do here is show us a scenario where we are missing that x squared term. And remember, I mentioned this earlier. If you're ever missing a term, you put a 0 as a placeholder. Let's see what that looks like. Okay, now we are dividing by x plus 2, which means we'll be using negative 2 into our synthetic division here. Okay, and that just means that if this was the factor, the solution would be negative 2. Okay. All right, so let's see. Coefficients, right? We got that 5. We said we're missing x squared. And the reason why we're using a 0 is because it's like having plus 0x squared there. And that's why that term is not visible to us, okay? So we're going to put a 0 there. Okay, we have the x, right? That's going to be a 6. Then we have 8. That's it. That's all of them, right? Okay, so let's bring down that first term. And then from here, negative 2 times 5 should give us negative 10. 0 minus 10 should be negative 10. Negative 2 times negative 10, positive 20. Then we have 6 plus 20, which should be 26, right? And then 26 times negative 2 should be negative 52. And then we have 8 minus 52, which should give us negative 44. Now let's just double check these numbers. Bring down that 5, right? Again, multiply here, we get negative 10. 0 minus 10 is negative 10. Multiplying negative 2 and negative 10, positive 20. Adding 6 plus 20, we do in fact get 26. 26 and negative 2, multiplying those, we get negative 52, and then 8 minus 52 is negative 44. Okay, this looks good, right? So this is our remainder, and then to write out our quotient, if we ever have to do that, this is the constant, this is the x, and this is the x squared. So that's 5x squared minus 10x plus 26 minus 44 over, what do we got there? X plus 2. There we go. Okay, so this is how we could write out that final answer. But, you know, this is the process of long division and synthetic division, which is what I really wanted to capture in this video. All right. I hope it was helpful. And we're going to be using synthetic division to find slant asymptotes. It could be helpful for finding zeros. You can use this for a lot of different applications in mathematics.